So hello world. We're going to dive right into this webinar here. All right. So hello world. Today we're going to be working with some TI and PHYTEC's latest hardware products and product offerings. We'll be using these to perform a live demo here at the end of the webinar. So please stick around. We're going to be utilizing some industrial Ethernet protocols and in conjunction with CodeSys development system, which is going to be used to actually set up and create these networks. And then yeah, and then we're gonna get into a very basic exercise of the hardware, and so that you can have an idea of what you could do with your projects someday. So we're going to take a look at the demo from a real zoomed in look and kind of blow out. And so first we're going to focus on just the processor itself. TI has a massive portfolio of processors featuring heterogeneous multi-core architectures, so you could find like a best fit solution, a best fit silicon for your processing, security, power, reliability needs. And what we do is we make rapid prototyping possible through a unified software platform, which is featuring like an Eclipse-based code composer Studio IDE for development and debug. There's other tools such as like graphical tools for pinmuxing, and then we have support for open source software components such as a mainline Linux kernel, RTOS, bare metal. Looking at the processor that we're going to actually be showcasing today, today we're going to be using the AM6442 Sitara processor from TI. It's designed with industrial applications in mind. What's unique about this processor is it has a very rich core set. So the primary features here are dual Cortex A53s, super high efficient general purpose computing. In this case today, we're actually going to be seeing the A53s running Linux on our main device. And then the AM6442 also features two dual Cortex R55s, or sorry, R5Fs microcontrollers. These are optimized for critical real-time applications. These are going to be running the free RTOS that we'll see in here a little bit on the secondary devices or the downstream devices connected via the industrial network. The AM6442 also features two industrial communication subsystems. These are two subsystems that are able to run proprietary real-time Ethernet stacks. So we're actually going to be doing that today. And each PRU ICSS is made up of like 6 independent PRU RISC cores, each of which can handle 2 gigabit Ethernet ports. So you can get up to 4 real-time gigabit Ethernet ports on the AM6442. And each of these cores has independent access to peripheral interfaces. So you can really consolidate very complex communication and control systems into super highly integrated chips. The software support for the AM6442 comes in 2 primary flavors. We have the processor SDK, which is TI's Linux distribution. It contains open source components and allows you to leverage community developed parts for rapid development, such as drivers. There's a lot of boards to reference in there that have already been defined, things like that you know and love from Linux. And so it makes it very easy to integrate pre-existing stacks. Like, for example, if your project utilizes Python, it'd be very easy to add those things to the processor SDK and very rapidly develop new products. On the other hand, we have the MCU Plus SDK. This is TI's RTOS offering. It's best for achieving the highest real-time performance for safety-critical applications. We're going to be utilizing both of these today in the demo. And so you really get to see the best of both worlds. Now, we have the AM6442 processor. What TI and PHYTEC have done in partnership we have developed a 5-core AM64X SOM, which modularizes the AM6442 processor. The goal here is to make it as easy as possible for it to be used in new designs. So the SOM consolidates all the high-speed, highest-risk circuits that usually give engineers like a hard time when you're actually laying out a PCB for a brand new system. If you use a SOM when you go to qualify your product's electromagnetic emissions, you can trust that us at PHYTEC here have pre-qualified the SOMs so that you don't have to worry about that being a point of failure in your qualification in your new design. At the same time, you can shrink your bill of materials. You can let PHYTEC manage all these common circuits revolving around the application processor. That would include, like you see here in the slide, the memory, flash, an Ethernet PHY if you option for that, and then the high density connectors as well. These are all components that allow you to very easily work with the SOM and then offload a lot of the worry with PHYTEC. An example would be like, let's say the eMMC does EOL due to a die shrinkage. You could let PHYTEC manage last time buys for that component, and then we'll also manage upgrade paths, redesign the SOM. We'll ensure that the SOM is footprint compatible so that you can keep your product, your end product, in production for as long as possible. We see products on the shelf for 10, 15, 20 years, having no issues with production, and they just have to upgrade to new SOMs that are footprint compatible. PHYTEC ensures that those are going to be available for you. So what we're going to be doing today is we're going to take the SOM and we're going to kind of paint the story of what you might be able to do with as a customer working with this type of device. The idea here is you take the SOM and you work with it with our development kit. The development kit kind of gives you an idea of like all the reference circuits that you would need to support your SOM and make sure that it's powered successfully and boots and does not give off too many electromagnetic emissions. And the idea here is once you have a prototype built around the development kit, you could then literally copy and paste circuits from the development kit that you know and trust that works, and then adapt them into a custom carrier board with pick and choose your circuits so that you cost optimize the size, shape, function of your board for your custom application. I'd like to actually really quick show you how that would work in practice. So in here on this is the demo that we're going to actually be doing later today. If I take a PHYTEC development kit and I actually prototype something with this, maybe an EtherCAT network like we're going to be doing, the idea is you could actually just pop off this SOM very easily. And then with these high density rugged connectors, then you can transition to custom carrier boards such as this Pinger board. Fun fact, this is actually the board we're going to be utilizing in this demo. We only got them like the other night, and so we didn't have time to get software ported over to them. But this is as easy as it would be to transition the same SOM. You could have software flash the eMMC on the board, or you could boot from external media like an SD card, and it allows you to very quickly iterate your designs and reduce risk. Rather than respinning a circuit for my flash, customers would be able to just focus on the circuits that matter to their unique application. All right. So today I'm going to be taking 3 AM6442 based systems and actually going to be daisy chaining them in daisy chained Ethernet topology. We're going to use a variety of industrial Ethernet protocols to exercise real-time control and synchronization of those peripheral hardware interfaces. The industrial Ethernet protocols here allow you to exercise determinism over traditional network hardware, such as like Cat5e cables, Ethernet cables in general, which make them a good, cost-effective solution for large-scale control systems. Today, we're going to be using the PHYCore AM64X development kit. Here you see at the top of the slideshow. And then, of course, featuring the SOM itself, which is kind of the brain of everything. The processor, the AM6442, is located here. This will be the main board, or what is kind of the terminology we're trying to get away, the master in terms of what they call an EtherCAT documentation. This is going to be kind of the conductor of the symphony of sorts. This main board will control the secondary boards daisy chain down the stream. And then that brings us to the secondary boards themselves. These are going to feature TI's general purpose evaluation module. These two boards are going to feature the exact same applications processor, the AM6442. Today, we're actually just going to be using them as 2 different reference platforms with circuits for you to reference in your own designs. So getting into the demo itself, we're actually going to be doing a very hands-on walkthrough of setting up a Profinet network itself. We're going to be doing this in a very manual way, setting it up from scratch. We're going to load firmware via JTAG. And then we're going to dive into, once we have a Profinet network working and we have something kind of cool working, live for everyone to see, then we'll dive into Ethernet IP and EtherCAT real quick. I've pre-prepped those off screen so that we don't have to like sit through that whole process of loading everything via JTAG again. And we'll showcase that these boards have multiple methods of boot. All right, and so let's dive directly into the webinar. real quick, there's an animation here that kind of showcases what's going to be happening. So the main board here is going to be sending out an Ethernet frame to the first secondary board. The secondary board is going to take in that data, grab what it needs to, process that frame on the fly, package in maybe some output, and then pass it on to the next secondary board. The idea here is these secondary boards can be daisy chained, and you could kind of blow this example up to n number of secondary boards. It's really going to be limited by the cycle time, the size of your data, and then the processing speed of each secondary board. Let's take a look at the actual demo now, and we're going to set up a Profinet example like I just mentioned. Look at that. Okay, I'm where I want to be. So what we're going to do is we're going to actually open up the Code Composer Studio. So this is the IDE I was talking about. It's Eclipse-based. And we're going to just go ahead and together import the MCU Plus SDK's Profinet example. So I'm just going to go here, right-click, import. We're going to hop into CCS projects, and I'm going to go browse. And I'm just going to locate where I am in the MCU Plus SDK. Real quick, Brian, are there any questions that I should address before I really dive into the demo?
Yeah, so there actually was a question about the upcoming Ethernet APL standard. And so what I'm reading here is actually that Profinet is one of the standard, Profibus is one of the standards bodies for Ethernet APL. So it's an upcoming standard. But I do have one clarification that I think it's a two-wire interface. So it might be something that we need to take a closer look at. I don't know if you're familiar with Ethernet APL yet, True.
I haven't heard of Ethernet APL. I do know that Profibus and Profinet are distinctly different protocols. So we might be talking about different things here. I'm not familiar with APL.
Yes, so Profibus is the overall standards body. Profibus and Profinet are part of the same group. But yeah, so that's the only question that we have right now, and I think it requires some additional clarification. But go ahead and continue with the demo, and I'll continue my research on the topic.
Okay, thanks, Brian. Okay, I'm going to keep diving in here. So just to recap, we're taking Code Composer Studio, and we're just going to install the default Profinet example. So we can see here, I'm just going to examples, industrial comms, into Profinet. There is documentation from TI on how to install the MCU Plus SDK. So I'm not going to go ahead and show that part. I'm just going to install this example. So we're going to select that directory. The project itself isn't going to be visible. And so once we have this example here, we can take a look at the code if we wanted. We're going to see here that this is actually a FreeRTOS example. I've also created a target configuration. The target configuration is just selecting which platform I'm working with. And this is going to be done over JTAG. What I can do is I can go ahead and link this project to the file, or link this target configuration to the project, excuse me. And then we're going to go ahead and build the project. I'm going to build a release version. And we're just going to see this build real quick live. And then with the project built, now I can go ahead and launch a target configuration. Before I do that, let's take a look at the hardware. What I'm going to do is I'm going to load this firmware over JTAG. So I'm going to need another micro USB port. What's nice about these the two designs featured on my table today is that there's an XDS 110 JTAG debugger integrated into the board itself. So in order to utilize JTAG, all you need is a micro USB cable. We're going to go ahead and connect it up to the first board here, the first secondary board. I've already configured my boot mode to no boot, which is the JTAG boot mode. We're going to flip that on. And you see that there's no output on the console. That's great. That's exactly what we're expecting. So back to Code Composer, I'm going to go ahead and launch the selected configuration. And we're going to utilize CCS scripts to initialize the sock. So this is going to bring up all the cores, and they're all going to be sitting in a reset state. And then now that they're in a reset state, I'm going to issue a CPU reset, which is up here at the toolbar. Now I can go ahead and run load program. And I'm just going to select that project I just built. which is here, the Profinet IRT RGMII demo. Profinet comes in a few different flavors, IRT and RT, and then as well as RGMII and MII. We're just doing IRT RGMII. This should be the fastest example. Inject that into memory, and then we can just go ahead and hit the play button. What I'm going to do is I'm just going to shrink this window so you can see what happens in the terminal. So this is the device that we're going to be controlling, the center one. I'm going to hit play and see what happens. Sweet. And so we can see that the Profinet stack is started up successfully. This is just the default example. You saw me import it and build it live. So now we're just going to real quickly, I'm just going to set up the second one. The way I can do that, I'm just going to kill this debug session, switch my USB port over. I'll just make sure you guys can see everything I'm doing here. Plug this back in on this board now, power it on, and we're just going to repeat that process to set up this secondary board. Bear with me. All right, and the sock is initialized, just about. And issue the CPU reset, run, load. I'm going to reload program, and I'll remember the last one I did. And then I can just hit play, and let's see what that looks like when I do that. Oh, there's something wrong with my serial console? All right, so this is a live demo. This is great. We're running into problems. Bear with me. I'm going to resolve them live so you can see how to do that. I'm just going to go ahead and try that again. I think maybe the reload button tried to load the wrong example. So I'm going to reinitialize the sock, and then we're just going to try reloading that again, a little more manually this time. And something is in a weird state. Let me just cycle power. It's as easy as this. Flip power. And I'm going to kill the debug session. And let's give that one more try. And something has gone wrong with my console. Bear with me. Hopefully, when you guys all go to do this project yourselves, you'll be able to reference back to our webinar, kind of pause and play through it and see how I resolve these issues. So I'm going to navigate to View, Scripting Consoles, get that window back up. It's got to initialize itself. And come on, Code Composer. All right, this may take a little longer than I was hoping, but I'm just going to do a quick restart of Code Composer. Find that this helps, and hopefully it won't take too long. Thank you for your patience, everyone. At least this board's working. Here we go. We're back. I'm just going to give it a quick second to load everything. Get my scripting console back. Let's try that again. There we go. All right, sock is successfully initialized. And now we should see the example play. Beautiful. All right. Now we can go ahead and kill our debug session. I can go ahead and unplug the JTAG connector. And we can see that our two Profinet secondary devices are now up and waiting for a master or main board to connect and kind of control them. So now we're going to go ahead and do that aspect. I'm going to go ahead and plug this in. So on this board here, we're actually booting TI's version 8 processor SDK. It's been ported by PHYTEC for use on our 5-core AM64X development kit. But otherwise, it's the same distro. It's going to be running a Rago Linux. And what I've done off screen before this webinar is I've installed a couple Debian packages required by the CodeSys. It's a runtime module that allows me to connect to this main board via the CodeSys development IDE. We'll be diving into this here in a little bit. This is a new window. But as you can see here, we're just booting in the Rago Linux, and this device is up and running. So now that it's up and running, and off screen, I've also installed this CodeSys runtime system service here. We can see that I've also named it Profinet just for convenience. Let's go ahead and build this example. So what I'm going to do is I'm going to navigate into CodeSys Development Studio. And this is the IDE that we're going to use to build our industrial networks today. I'm going to right click on this, and we're going to go to Add Device, PLCs, and we're going to add this Linux ARM 64-bit control package here. Actually, this is a device. So this is a generic device. This will support the AM6442 processor. Close this. And I'm going to go ahead and rename this project for what we're going to be doing today. That's just Profinet, make it something meaningful. And now I'm ready to go ahead and build out my network, my Profinet network. In order to do that, we're going to go ahead and add a Ethernet adapter field bus. We can find that here under field buses, Ethernet adapter, Ethernet. And then everything's built very hierarchically here in CodeSys. So we're going to go ahead and add a device to that Ethernet device. And we could do that here at Profinet IO master, PN controller. This is the Profinet controller we're going to be using to control the secondary boards we set up together. All right, and so now I got my network somewhat set up. This is a bare bones CodeSys network project. What I can do now is I can scan the network and look for any devices on my local area network, my LAN, to see if there's something running a CodeSys runtime. In this case, in my 5-core AM64 development kit, and I got a little password here that I set up off screen as well before the webinar. This board here is running that CodeSys runtime. And so because it's connected to my local area network via this beige looking Ethernet cable, I'm able to scan for and see this 5-core AM6 development kit, codename 5-board Electra. You can see that name here. And now we need to do some configuring to set up the rest of the network. First of all, we need to tell CodeSys where is my network connected to. In this case, we're utilizing this red cable for the EtherCAT network, and that is connected to Ethernet 2. And so all I need to do is I need to go ahead and provision that into the Ethernet device here. And we see that Ethernet 2 is listed here, and this is the static IP address that has been set up on that on the target. The way we can look at that here, I'm just going to go ahead and blow this up real quick. Oop. We can see that Ethernet 2, this is that Ethernet interface that is being reflected here in CodeSys. So I'm going to select that port because that's where my secondary boards are connected. And then here in the Profinet controller, this is a nuance of Profinet. All the protocols have slight nuances and differences in how you set them up in CodeSys. They're very similar though. We're just going to have to specify the range of acceptable secondary or slave IP addresses. So here we have to make sure that we have a range set. So now I have all these things configured. I can go ahead and actually log into the network. This will build a application. Oh, I missed something. Quick. Because I have multiple projects here staged in this workspace, I'll have to select which project I'm going to be running. And that's done via this drop-down window up here. That took me forever to realize, by the way. And we're going to go ahead and log in. All right, and so once we log into the project, CodeSys will actually build our project. It'll compile a binary, deploy it to the target, and we can actually go take a look at that binary if we wanted to. It's actually stored here in PLC logic in the root directory. And under application, and this is the application binary. It comes in two files. We could actually generate that individually to generate code through here. And so when I kick off and log in, that application binary is deployed automatically, and then we're left in like a breakpoint state. See, I have to hit play here for actually things to happen. And once I hit that play button, now I can see that my Profinet network, my Profinet controller stack is actually running, and that's symbolized by this orange spinning wheel. The orange is indicating here that I have a trial license. I don't have a full license on this AM64 development kit, but you could go ahead and pay for that and actually deploy the system in production if you'd like to. Right now, this will just kind of expire after some trial period, maybe like an hour. So now that I've gone ahead and logged in, I can right-click this device, and I can scan. Let's scan a couple times because I know there's two devices. There we go. They disappeared. Okay. And because of the first time I'm setting up this Profinet network, again, this is another Profinet nuance. You don't have to do this for the other protocols, but I'll have to provision a name and assign an IP address to these devices. And it has to be within that good range that we set earlier as well. We'll start at 2, and then this one will be 3. 192.168.1.3. Okay. We'll select both of these and we'll set their names and IP. I always get this error when I do this, and I'm not sure what it symbolizes. I might have to reach out to CodeSys support. Alrighty. And now I can see that my two devices here are reflecting the names I just set, as well as the IP addresses I just set. And now we got a little insight on what we're going to be getting into in a little bit. This is process data. This is data that's being advertised by these secondary boards. We're going to do something cool with them here in a second. For now, let's just go ahead and select both the devices and copy them to the project. We can see those devices here now listed here on the left side of the screen. The way you build out these projects in CodeSys is every time you log in, you're recompiling your application binary and deploying it. And so in order for me to update the system with knowledge of the devices that are connected to it, I'll have to log out and log back in. And so if I do that, now I can see that these devices should now have symbols next to them indicating that they're being a part of the network. If I hit play, we'll see that they're running. Now, these ones are having an issue because they're not actually doing anything useful right now. I'm going to go ahead and log out. And we're going to go over to the device. And in here, I can go to the I/O mapping. So my example that I've prepared for you today is actually going to leverage the first output byte. And so that's going to be this process data device here. Everything in here is like a nested device, the way it's represented in CodeSys. And so I can select this first output byte, and there's many different sizes of these packets of data that you can include in every Ethernet frame. And they're of adjustable size, and you could imagine that you could store different types of data in here, maybe motor position, maybe color information, things like this. The output here, I'm going to just have mapped to some LEDs, and we're going to do some cool blinking. And the way we do that, open this up, go to the I/O mapping, and I'm going to take a look at this first byte because I know that this is what I've mapped on the device. That's actually done by default in the TI MCU Plus SDK examples. I'm going to go ahead and select the way I did that, double click this cell here, and then use those ellipses, and you would have variables available to map to those individual process data, this first output byte. And notice here that I don't actually have anything useful. I'm not actually even sure what these are. I haven't looked into them. In order to do this, I need to set up some variables. And in order to set up some variables, I have to actually write some code. The way we're going to do that is go over to application on the left. And we're going to go to add object, add POU. And we're going to name this PLC PRD. And there's a bunch of variety of different methods in which you can program PLC controllers. I'm going to use structured text, but as you can see, there's a bunch of them. Some of these are like very graphical, like click and drag, block diagram looking. This one is a very like code, like, C looking code, which I feel more comfortable in. And I've gone ahead off screen as well to prepare some software here or not really software, but just like some simple scripts to do something useful. So I'm going to copy that in from off screen. And after I copy it in here, we'll take a look at it a little bit. Okay. So you saw me create this PLC program, and I've gone ahead and pasted in some information. I've created a variable here, I2C LEDs 1, and I'm mapping this to QB0. QB0, this is actually one of those process data from one of my downstream devices. If we go take a look at GPVM1, and we can see that that first output byte is QB0. Now that I've defined these variables and set them up in this way, I can actually now go to this cell here, double click, and now I can see that my application is listed. And I can see what variables I have. I'm going to map that to this variable. And I'm going to go ahead and do that to the other device as well, because I want to control both of these different systems in a synchronized way. I want to control both of them. So we're going to go to that first output byte of the second device, and then we're going to map it to that second LED, I2C LED that I've set up here, 384. And we can see that that's 384 here. Okay, now I don't need these guys. Now, if I go ahead and try to build this project and deploy it again, it actually won't work yet because this PLC program isn't belonging to any tasks. So in order to do that, I have to create a task and then add that program to it. So we're in the main task now, and we can go here and add a call to the PLC program that we just created. All right, and so now we have this PLC program queued up in a task so it actually run. Now, some of the things that I didn't talk about here in the PLC program, there's some useful counter variables. We have a T-cycle variable. This is actually going to control the cycle time of my system. And then we have a couple of these here, these TONs. This is a time on delay. You have to go check out code documentation to know a little bit more about this. But essentially, it's a way of implementing a delay function on rising edges. And so I'm going to utilize this time on delay throughout here. You get the output with this .q syntax. I'm going to utilize the time on delay in order to toggle the LEDs at a rate of my choosing. And we can see here, I'm just going to be shifting some bits. LED 1, these are the individual bits that make up the byte, if that makes sense. And I'm going to be shifting those bits here. We're going to shift over bit 8 over 7. Number 7 here, we're going to shift over 6, yada, yada, yada. And then delay for a certain amount of time. Then we're going to rewrite those bits with 0101 data, store those back into the byte, and then we're going to flip it with 1010 data. So we should see an LED pattern on the two slaves or secondary boards where the lights kind of shift back and forth together. Let's go ahead and see what that does in action. Sorry, my phone went off. Forgot to put that on silent. Excuse me, everybody. And looks like we ran into some errors. Perfect. So I actually wanted this to happen. We're going to resolve these together. Look at this. Unknown type, TON, time on delay. That it comes from CodeSys. Why the heck is it not being recognized? Well, we have to actually import a library, very similar to other programming languages like maybe Python. We don't just get access to these things by default. So we're going to head over to the library manager, and we're going to add a library. We're going to navigate to application common standard. That's where the time on delay comes from. Okay, and so now I should be able to compile this with no issues. And we can hit play. We can see that our stack is running nice and happy. Oh, and the second device took a little bit longer, but everything's looking good. Now let's take a look at the hardware. And we can see here, I have a I2C LED array with that process data actually mapped to the states of these LEDs. And we can see that the two boards are shifting their LEDs back and forth. Now, they should be shifting in the same direction. They look like they're in opposite directions right now. I don't know if you could even tell, but the reason is these are slightly different revisions of the GPEVM, so their layouts are slightly flipped when it comes to these I2C LEDs. these are essentially making the same LED pattern on both boards right now. So that concludes Profinet. Real quick, while I still have time, I'm going to run through Ethernet IP first, and then we're going to dive into EtherCAT real quick. And the advantage here is the AM6442 supports many boot media, so I've actually pre-prepared these other examples on other boot interfaces so that we can flip to them real easily. So the way I'm going to do that is I'm just going to bring the system down, and I'm going to switch the boot modes. Ethernet IP is the one we're going to check out next, and that is going to actually be flash, the OSPI flash on these boards. The way I can flip that is just controlling these two boot mode switches here. So just give me a second while I concentrate and make sure that I get these correctly switched.
Now is the perfect time to let True concentrate on the dip switches and ask if there are any other questions that anyone wants to type into the chat. We had some questions earlier on different protocols or extensions of Ethernet and other industrial protocols. Any other questions? Please type them in the chat or the Q&A. As I said in the chat, True loves to be interrupted with great questions, except when he's toggling dip switches.
All right, and so what I've done there is I just switched to OSPI boot mode, and we can see that I've off screen before the webinar today, I've actually just installed and built those default Ethernet IP examples, just like we did with Profinet. So I haven't really modified anything here on the secondary boards. And you might have saw me switch the SD card for the main board here. That's just because I've provisioned this SD card with another CodeSys runtime specifically set up with an Ethernet IP network that I built just the same way with CodeSys. You guys just saw me do that live with Profinet. I've just done this beforehand. And now that my Ethernet IP network is up, I can just take CodeSys. Let me close out all these older files from the previous example. Remember to select which project you're working with. So Ethernet IP up here at the top. And then I'm going to collapse this guy, open this guy up. And now let's scan for our main board again. And we should be able to log right in because I've set all of this up previously. There we go. And let's take a look at the boards. There we go. So this example is very similar. I've gone ahead and built this out in the same way. There are slight nuances in the way you set this up, Ethernet IP versus Profinet. We can see that this looks very similar though. The first output byte, I got it mapped to a couple LEDs. One for, I've done this for each of the secondary boards. And then we can also look at the program code. It looks very similar. Very, very similar. I've mapped a few more LEDs in this one. Profinet was set up to map individual bytes. I can actually address specific bits now, and that's what I'm doing with this .0 syntax. And so that's why there's no byte variable anymore. And so when I log in, the nice thing about this is it actually visualizes the blink pattern. So we could like take a look at this in right next to the actual hardware, and it should line up like perfectly. So you can see here on the board, and things are moving here in tandem with the CodeSys development system on my host machine. Okay, so now we've showcased Ethernet IP. Now I'm going to real quick and just showcase EtherCAT and just show you how quickly I can switch everything over. And EtherCAT, I'm actually going to be booting from SD card in this case.
All right, True is on the clock. Last 3 minutes. We promised 3 industrial protocols in 30 minutes. True likes to run right down to the wire. So 24 minutes for the first one, 3
I got my
minutes for the
switches
second
wrong.
one. Oh no, this is where it gets dangerous.
Yeah, I'm gonna run out of time.
We need to get EtherCAT done. Man, 2.5 minutes here. While
we got the
we're
EtherCAT stack booted
restarting,
up. I'm gonna boot up the main board, and again, this is another just the Linux board, Linux SD card that I provisioned with the CodeSys runtime again, but this time I pre-built an EtherCAT network off screen. So again, it's a very similar process that we saw with Profinet. And any second here, we should see, yep, there it is. CodeSys runtime EtherCAT master. And it takes a little bit for that stack, the CodeSys runtime, to actually start up. I'm not sure what, it's a closed source binary. Everything from CodeSys is proprietary, so you don't get a lot of insight on how their components work, but it's a very useful tool and very powerful for controlling, large scale control and communication subsystems. And so in this case here at the EtherCAT, we can see that as soon as the runtime is up and running, we can see that these secondary boards were acquired. And in this case, I'm just doing a all on back and forth between the two boards. And they're operating in a very tight time schedule. And that concludes my live webinar. So we've gone ahead and taken a look at, let me pull up the slides real quick. Just a recap. So we built a Profinet network together. We utilized the CodeSys development system on my host machine, connected to the master or main board, in this case, the PHYTEC AM6442 development kit, connected on my local area network. And then this main board was then connected up to a couple secondary boards via daisy chain Ethernet. And then we utilized JTAG to load the secondary boards here. Over JTAG, we loaded them with default Profinet firmware, and we're able to control their LEDs, their hardware interfaces here, right there, with this kind of stair-step shuffle back and forth kind of pattern. And then we also did this very similar thing with Ethernet IP. We booted this one from OS5 Flash, and then we did a slightly different LED pattern. And then for EtherCAT, again, it was a very similar process, but with a different LED pattern again. All of these protocols, just to kind of recap, they aim to solve the same goal of exercising determinism over Ethernet hardware. And so that's why we're seeing them essentially do the same thing. That's just for convenience of my demo. The idea here is when you create a new device for a new network, you would just pick one of these to support a particular environment, or maybe your OEM that you are working with, or maybe you are the OEM. You would just have a lineup of devices for one of these protocols. So you wouldn't mix and match these. And what are we working towards? Well, what we at PHYTEC and TI would like to do is take this Pinger demo that I showcased with you guys and use it to make a new 3D printer of sorts. We're going to call it the plotter, a pen plotter. This is going to be a trade show demo that hopefully you all get to see live someday. We're going to be able to take it to a trade show, put it on a table, and it's going to hand draw a picture for you and some business information so that you can take it home. The idea here is we're going to utilize EtherCAT network, and each access of the printer, each motor is going to be controlled by an independent system, and we'll be able to daisy chain them like we saw today. And then in this case here in this diagram, we're actually even leveraging, we're going to leverage a redundant loopback from that last device. So if I took some scissors and literally cut the Ethernet cable here, my master or main board would still be able to address and reach all the devices. That's something that's supported in the EtherCAT protocol and will be supported here in MCU Plus SDK. It's not something I've worked with myself yet, but I'm hoping to get there. It looks really cool. And that just about concludes my webinar today. So we got a whole lineup of hardware here for you to bring new and exciting designs to market featuring the AM6442. And we're really excited to work with TI on it. Please check out the QR code here at the bottom of the screen. I'll zoom that in, where you can learn more if you'd like. Brian, anything I missed?
I don't think you missed anything, but we have 6 minutes left. Maybe you can zoom in a little bit
I
more
was
on that
seeing like a
QR
little
code. Hold
notification
on.
saying I was too slow.
Let
So
me.
I was like, I gotta go.
Now you made it in time. All right, let me check. The QR code is active and working. I can get it on my phone. Let's hang on to that last slide with the QR code. And any questions from anyone on the line? It looks like we have a healthy number of people still attending the webinar. I know this goes very fast for me, not being the expert that True is. And there's a lot of different components. So any questions we can answer in English, Mandarin, I don't know, maybe True can answer in Japanese, but you can type them in the chat, or if you have a question, we could unmute the lines as needed so that we can speak in the correct fluent language. Well, I'm not seeing any questions yet, but we probably have some people that are wondering more about this demo. So feel free to ask the questions now. If you do have any follow-up questions after the webinar, we will post the webinar itself and the presentation from PHYTEC on the same site where you registered. So when you go to the landing page there, it will have the on-demand video as well as the presentation. And you can, of course, go to support.phytec.com and answer a question that way, as well as the E2E portal. So you go to e2e.ti.com or the Chinese E2E version as well. For anyone that joins late after our introduction, we do have Gentle and Claire on the phone. Gentle or Claire, maybe you want to unmute and ask if there are any questions. But yeah, one thing worth mentioning from the questioning, I know True mentioned this, the programmable real-time unit is what True was referring to with the AM64. So the PRU is a multi-purpose interface, right? So it's programmable real-time unit industrial communication subsystem. So it's a mouthful, so we call it the PRU ICSS, and that allows you to achieve not just a single industrial protocol, but a variety of them, and they can be programmed however you see fit. So I think the Pinger Lite expansion board is taking advantage of a lot of the PRU pins through the GPIO header. And then one of the other questions was about, I think it was a 2-wire Ethernet, which is now named Ethernet APL. I don't know if that's specific for automotive, but we do have some automotive PHYs that were pointed out. And so the key here, I believe, is that RGMII is the interface that is preferred. So RGMII out of the processor into the Ethernet PHY, and then you can convert it to standard Ethernet or 2-wire Ethernet, however you see fit.
I'm going to piggyback on you there actually real quick, Brian. The Ethernet IP and Profinet protocols both support an RGMII version of the protocol. EtherCAT is specifically in 100 megabit. It's in MII mode.
There is one question. Is the code running on the slaves or the downstream devices also provided by Codesys?
Great question. So that code that we built that firmware from the MCU Plus SDK from TI. Now that MCU Plus SDK in that example, the EtherCAT, Profinet, and Ethernet IP examples, they leverage closed source libraries provided by, I believe, CUN bus to actually support those industrial protocols. But the software itself is from TI, and it's included in MCU Plus SDK. You can take a look at it yourself there. Yeah.
There is another question, but just an extension of what you asked, right? So Codesys is a runtime environment for PLCs. CUN bus is the included protocol stacks that are part of the TI SDK, and they run on specific AM64 and AM243 devices that have those stacks enabled. So they're included as part of the processor. The follow-up question is, which field bus stack vendor does TI use? Field bus, that's an interesting question. I was talking about it with one of my colleagues. the other day. So everything in this presentation is specific to industrial Ethernet. That's not to say that field bus can't be supported, but field bus and industrial Ethernet are kind of competing technologies. So I don't believe CUN bus offers any field bus stacks. I could be wrong on that, but there are additional details on, I think Profibus was the one that we were talking about earlier. Profibus and Profinet are on opposite ends of the field bus and industrial Ethernet from the same standards body. So regarding that, I think the best answer to that question is if you look back at the AM335 and I think the AMIC 110, we supported both Profinet and Profibus. I think right now there isn't an urgent need to implement Profibus on the AM64, but if that is needed, you can certainly highlight it via the E2E forum. But yeah, from our perspective, I think industrial Ethernet is the majority now and gaining share. All right, well, I think we're a little bit over time, but we have one more question. So True, if you're willing to stay on, maybe you can hang on and answer this question.
Yeah, no problem.
Are the masters running on PRUs or just Ethernet port?
Great question. So the master, in this case, was a system running Linux. And so the Linux there is provisioned with a CodeSys runtime Debian package that I've set up in a system service that you saw in the boot log. So in this case here on the development kit, I'm actually utilizing one CPSW Ethernet port connecting the master to my local area network. And then for the actual industrial Ethernet network, I'm utilizing a PRU Ethernet. I can actually go ahead and show that again, just to point out on the physical hardware what that looks like. So this is the CPSW Ethernet, and this is connected to my local area network. These are PRU Ethernets. I'm actually utilizing them to communicate with my slave devices. I'm utilizing PRU Ethernets here on the secondary boards, but here they're just operating as any other Ethernet port. You could utilize any Ethernet port. I could have used the CPSW Ethernet port to daisy chain the network as well. And then I have the Pinger Lite, which could give you options of getting more Ethernet ports.
So the maximum with both CPSWs and the PRU, I think, is 5. At that point, you would have to switch to an Ethernet hub.
Right.
So we did have another question, and this actually, I'm not sure if it's already been provided. So True, you used some of the documentation and the tutorials from TI. Was this demo CCS project already provided as part of the tutorials that you started out with?
Yeah, so the MCU Plus SDK I used and imported that example from, that's currently released in public. So you could take a look at it. It's version 8.01 of the MCU Plus SDK. We'll be putting out like documentation to recreate this demo yourself if you'd like, and then information on like what we modified to get things to work on our development kit, and then the GPVMs. That's just default firmware from that MCU Plus SDK that I talked about. Actually, real quick, I'd like to address Lule's question from before. It looks like he also asked, does this require RT Linux? That's a great question. It's actually recommended by CodeSys to run RT Linux for the master. I didn't, so it does work still. I assume you would get better latency with an RT Linux running on as the master, but I didn't do that today.
So just as a follow-up to Kevin's question, I was just going to say, so we didn't mention this at the beginning of this webinar presentation, but there is an additional webinar from TI that starts with EtherCAT, and I think it focuses mainly on EtherCAT and Ethernet IP, and that might more directly reference the MCU Plus Academy. but I will also link to the MCU Plus Academy. That way you can browse what we call the Resource Explorer for the MCU Plus SDK. So that link isn't dedicated to the industrial Ethernet stack, so it's the whole academies, but there is one that is dedicated to industrial communications, and that link is, I believe, get refreshed. That link should be separate. Yeah. So that link here, if you go to that page, it'll dump you out onto the Resource Explorer, and that shows the original EtherCAT example, Ethernet IP, and Profinet, all using the TI EVMs. The advantage of working with PHYTEC is that the module is already designed. You can design any carrier board yourself, as well as getting the custom carrier boards done, right? So if you needed 5 Ethernet ports using the CPSW and the PRUs, then you could add those in through a custom carrier board and get a form factor that is ideal for your application.
Also to mention up there too, PHYTEC wants your designs to succeed. That's why we bring to market system on modules. We also perform free schematic reviews to ensure that your SOM can actually work with your new boards. So from the development kit with the reference circuits all the way out to free circuit reviews and schematic reviews and ensuring your success, PHYTEC and TI would love to work with you all the way.
Well, it looks like that about wraps up the questions that I see here, and we are 8 minutes over time. I'm happy to hang out with True all evening. Maybe he has some more birthday cake to eat. Well, thank you everyone for joining. This has been the Industrial World demo presented by PHYTEC, and that wraps it up. And we'll post this on the web along with the presentation in a couple of days. If not tomorrow, then check back on Monday. Thanks again.
Thanks, everyone.